Hello everyone. In this video, I'm going to talk about systems. In advance, I'm going to talk about what is a system, how to develop a system, system development methodologies, system development life cycle, waterfall model, spiral model, rapid application development, and agile model. System is an interrelated, interdependent components which link together according to a map to achieve a specific object or a goal is called as a system. That's the definition of the system. A system contains inputs, outputs, and process. System can be mainly divided into two groups: closed systems and open systems. Open systems. In open systems, the inputs have been taken by outside the system border, and the output have been released beyond the system border. Then in closed system, the input, process, and output, all the things are happening inside the system border. System development. The process of creating and maintaining information systems is called as a system development. Software development process. The structure of developing a software is called as a software development process. Domain analysis, software element analysis, specification, software architecture, implementation, testing, documentation, software training and support, maintenance. Let's talk about this in briefly. Domain analysis. This is the first step in software development. In this stage, we analyze that whether the new project can be done by upgrading the existing system or whether we have to build up the whole system. System element analysis. In the above stage, we gathered information only from the client. The client only knows that what they want, but they do not know what the software should do. So requirement is being recognized by skilled and experienced software engineers. Specification. The SRS document or the system requirement specification is a document that says what the software should do and how to perform the exact output. Software architecture. This is the abstract depiction of a system. Implementation. Converting the algorithm or the SRS to a software or a program. Testing. In this stage, the QA, quality assurance engineer, and the software engineers work together. QA checks whether the program gives the exact output that the client needed, and he checks the errors done by software engineer. Documentation. The next step is to document the internal design of the software because it might need in future maintenance. It might be useful when the user needs to expand the software or the user comes over with new requirements or new problems. Software training and support. The user of the new software are unfamiliar with that. So it is important to give training to them to learn how to use the system more efficiently and should make them more familiar with the software. Maintenance. The software development company should stay backing to the user to a certain time period because the user might face with new problems and new requirements. Then let's talk about system development methodologies. There are four main system development methodologies: SDLC, system development life cycle, structured analysis and design, data-oriented methodology, object-oriented methodology. Firstly, we talk about system development life cycle. The system development life cycle has several phases, and those phases are as follows: planning, analyzing, designing, implementation, and maintenance. The waterfall model. In the waterfall model, there are also several steps: problem definition, requirement analysis, system design, system implementation, system testing, and maintenance. This waterfall model is also called as the traditional approach to software development and also as linear sequential life cycle model. You have to complete the first phase completely and then only you can go to the next phase. This is so familiar to a real waterfall because the method flows only forward wise. The waterfalls doesn't flow backward. Strengths in software development life cycle. The user requirement had clearly identified in the early phases. Easy to understand and use this deploy development method. The requirements are stable. In this method, it gives more quality outputs. There is a strong structure for the inexperienced staff. Project is completely depending on the team that works for this project. Drawbacks. This development method has high risk. This method has a firm design, so the procedure are flexible, inflexible. You have to finish one phase completely to go to the other phase. Phases cannot be repeated or go backward in the phase are more costly because the phases are most costly. Cannot be used in complex projects. Errors can only be fixed in the testing phase. Clients interaction is less in this method. No working software is output until the life cycle ends. Cannot deal with ambiguous requirements. Cannot measure with the progress within the phase. Where we can use this system development methodology. This method can be used in projects that can clearly identify all the requirements in the first stage. There cannot be ambiguous requirements. If the project is inexpensive, small, simple, and if the project has no exact deadline, this is good for projects that have inexperienced members. This method is good for management control systems where it is least appropriate. Large and complex projects that the client expects to change the requirements when the time passes. Real-time systems, event-driven systems, leading-edge applications. Then spiral model. This is a picture of a spiral model. The spiral model is a combination of prototyping model and the waterfall model. This method can be used for large, expensive, complex projects and provide support of risk handling. Spiral model contains mainly 4 phases. Determine objects, identify the resolved risk, deploy, development and test, plan the next iteration. A software project repeatedly iterates through these phases is called a spiral. Determine objects. Identifying all the requirements and problems as much as possible by interviewing the client and the other users of the system. And also have to study the existing system if the organization or company have an existing system, either manual or automated. And then alternative solutions possible for the phase is being proposed. Identifying the resolving risk. In this phase, given possible solutions are being evaluated and select the best possible solution. Then the risk is selecting this solution is being discussed and solved it by the best possible strategy. Then a prototype built up for the best possible solution. Development and test. In this quadrant, the identified features and the solutions are developed and being tested. At the end, the next version of design prototype of the software is derived. Plan the next iteration. A second prototype being derived by evaluating the strengths and the weaknesses and risks. Define the requirements of the second prototype. Then do the previous steps again. This method having this type of loops, so that we call this method as a spiral method. Strength of this method can be used for highly risk projects because there is a high amount of risk analysis. can be used for large and complex projects. Additional functions requirements can be added when the time passes. The customer is with the project team throughout the project to accept the prototypes. Software produced early in the life cycle. High user visibility. Weaknesses. Weaknesses. A costly model to use. Lack of risk management experience. Lack of milestones. Success of the project highly depends on the risk analysis phase. Doesn't suit for smaller projects. Situations where this type of models are most appropriate. Large and high risk projects, the projects that customer can interact anytime with the developing team. Projects which changes may be needed anytime. Projects which cost and risk analysis is needed. Doesn't suit for smaller projects. Situations that least appropriate. Doesn't suitable for smaller projects. Cannot finish the project quickly, so doesn't suitable for quick needed projects. Rapid application development, or RAD. In this method also we are having some steps: business modeling, data modeling, process modeling, application generation, testing, and turnover. RAD, or rapid application development, is a software development methodology with minimum planning in favor of rapid prototyping. And this is a linear sequential development process that having faster development and higher quality result. RAD contains mainly 5 phases. Business modeling. The first one is the business modeling. This design in terms of flow of vital information in business is generated by the BA, business analyst, and the model in the way that answer the following: how it can be obtained, how, when is the information processed, what information drive the business process successfully, who generates the information, to where does the information goes, who processes it. Data modeling. The information collected from the business model is reviewed and analyzed in the desire of formatting data objects vital for business. The attributes of each object identified and defined, and the relationship between these objects are established and well defined. Process modeling converts the data objects that were identified and defined in the data modeling phase to establish the information flow to acquire specific business objectives. For any changes or updates to the data object sets is defined, and the description are created for adding, modifying, deleting, or retrieving a data object. Application generation. The system is being created in here, and the coding is done by using automation tools such as VB, Delphi to convert process and data models into actual prototypes. Testing and turnover. The overall testing time is reduced because the prototypes are being tested independently during every iteration, so a large number of components have already tested. Because of this, it reduces the risk of any major issue, but the data flow and the interfaces between all the components need to be tested by a complete test coverage. Advantages: can accommodate with changing requirements. Development time is reduced. Progress can be measured. Increased reusable components. Customer always interact with the developers. There are quick and initial previews. Testing each and every prototype individually from the beginning is so it minimizes the errors and saves time. The iteration time can be reduced by using powerful RAD tools. Disadvantages: requires highly skilled developers, or designers, require the user involvement through the cycle. Suitable for the projects require a shorter development time, depends on the team and the individual performance. highly depends on the modeling skills. Should not use for cheaper projects because the cost of modeling and the code generation is very high. Situations were most appropriate. Projects that having short to medium time duration. It should be used only if the designers for modeling is highly available. Should use where the requirement changes frequently during the project and the prototype can be present to the customer throughout the project time period. The business objectives have to be well defined and narrow because the project scope is focused. Situations where least appropriate. Very large projects, real-time or safety critical projects, the projects that the scope is broad and the business objectives are obscure. Agile method. This model mainly focuses on the process adaptability and customer satisfaction. In this method, the project will break into small coding parts. Each part has iterations and each iteration will end by 1 or 2 weeks, 1 to 3 weeks. And also a cross-functional team will be involving parallelly on various areas like planning, requirement analysis, designing, coding, unit testing, and acceptance testing. At the end of the iteration, working software will be displayed to the customer. In Agile, the task is divided into frames and then the iterative approach is taken and a working software will be delivered after each iteration. Each frame that had been built is being implemented in terms of features and the final product hold all the requirements given by the customer. This is a picture of the Agile model. Following are the system development methodologies: rational unified process, Scrum, crystal clear, extreme programming, adaptive software development, feature-driven software development, dynamic system development method, Kanban, TDD. Agile Manifesto. This has been published in 2001 by a software engineering team in order to highlight the importance of the development team, accommodating changing requirements and customer involvement. Advantages. Most realistic method to software development. Promotes team work and cross-training. Functionality can be developed quickly and displayed. Suitable for fixed or changing requirements. Little or no planning required. Easy to manage. Flexible for developers. Disadvantages. Not suitable for handling complex requirements. An agile leader and agile PM should practice in overall plan, otherwise the project will not work. Depends heavily on customer interaction. This methodology highly depends on individual since minimum documentation. Transferring the knowledge to a new team is hard due to lack of documentation. Situations where most appropriate. If the team members are self-motivated and ready to take any changes, is the customer okay with being connected with the team anytime? And the least appropriate. Not suitable for projects that have complex requirements, not suitable for projects that customer cannot interact anytime with the team. And that's all. Thank you.